The atomic singularity is, why is there a singularity in the middle of an atom? The supersymmetry inversion model suggests that four particles are created from an inward trajectory from the initial helium Bose-Einstein condensate at a square root speed of the outward velocity. So the alpha particle goes out as dark energy, and then there's an inward trajectory that produces the dark matter particle. And so we have this kind of conceptual framework that at the center point of every atom, there is this kind of structure where the distance between the particles is kind of the Planck length. So rather than the Planck length being this epoch moment after the hot Big Bang, in the supersymmetry inversion model, it's actually created after 13.8 billion years of the inward trajectory, producing the dark matter particle. And so here we have a inverse square law relationship between that kind of H. Remember I talked about the H squared, and so the square root of H gives 4e to the negative 18. So these particles surrounding the that kind of singularity are larger, and you get to understand that by doing the square root of H to give 4e to the negative 18, and that corresponds to the 2 positrons and 2 electrons. So the idea is that there's this dark matter particle down at the singularity that surrounds the singularity, and it's like a framework, right? A framework that's been able to then undergo an atomic decay. So in this supersymmetry model, that initial universe, the Hebek isotropic universe, had no mass, no charge, no space, no time. And every action having equal and opposite reaction. So we've got alpha particles or dark energy going out, and the dark matter coming in that kind of gravitational trajectory inward. So you've got 4 coming from either side, getting closer and closer and closer and closer and closer. And now they're at that singularity state, that 1.6e to the negative 35 of a meter. So they started at 4e to the negative 14 of a meter, which is the 0.00004 nanometer scale, and they've got closer and closer together. That as a model produces this framework, right? So this framework, really, the H squared, I'm saying, is 4e to the negative 18 of a meter in terms of the square root of H. I know that's weird to be going on about using square root rather than squaring, but that tends to be the way in the quantum state. And so I've also developed a way of understanding how these 4 particles undergo a isotopic decay system, or generating a neutron and a positron, right? So this is what the anti-hydrogen is coming from in the supersymmetry inversion model. So we have these kind of 2 electrons, 2 positrons. They undergo a rearrangement, and that rearrangement ends up producing a neutron and a positron, and the overall charge of that is 0. But then when you look at the quark calculations that I'm doing in that kind of boson statistical analysis, where I'm using 1 and negative 1 for my quarks, so that there's this kind of process that generates the 3 quarks from the 2 photons. And that's all happening in that kind of singularity. So what I see is the 2 of the 4e to the negative 18 scale, they multiply together to get 1.6 e to the negative 35. So there's an upfield shift to a higher energy and a smaller wavelength. So they've combined. And then we have a relationship between the square root again of one of the other particles. So that goes down to 2e to the negative 9. And so we have the 1.6e to the negative 35 and 2e to the negative 9. And that corresponds to a distance that the electron is going to be kicked out of the singularity through a quantum tunneling and entanglement process with its other photon positron partner. So we have two positive quarks and one negative quark to give us an overall negative neutron in the supersymmetry inversion model. And because the neutron's associated with a positron, and because what was an electron gets inverted through the singularity to come out and be entangled with that other positively charged down quark, it becomes a positron in the orbital layer. I kind of hope you can follow the logic. What I'll do is I'll help. I'll go through this again and that kind of meson W boson type beta plus beta minus decay system that's operating to provide a neutral state within the atomic landscape. But I really just wanted to show that there's this kind of feature within each atom which gives the inertial frame of reference down at the atomic singularity of 1.6 e to the negative 35 of a meter, and that's really corresponding to an inward trajectory of the kind of dark matter particle that's generated as a positron and neutron pair. And yeah, it's a beautiful system. It happens to coincide with a quantum tunneling and entanglement system that inverts charge from an electron to make it positively charged from negative. And so we really got to think about why there's this handedness in the beta decay system with W bosons, and why there's a neutrino or an antineutrino and the handedness of those. And that corresponds really to the initial formation of the particle through quantum tunneling of a two-photon system down at the singularity state. So that's really kind of it in a nutshell. I know I need to provide some framework mathematically, as well as kind of like a step-by-step guide to understand what's actually going on in this atomic singularity. How did I figure this out? Well, like I've said, I've gone back through a supersymmetry inversion model, rearranging quark charge calculations, making them have charge parity with positron-electron pairs. And so really the model predicts these are the features operating within the atomic singularity within an atom. And that's really like tuning back beta decay systems in order to look at what the structure was prior to the decay. Anyway, I'll talk about that in another video. Thank you for listening.